The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseWare continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseWare at ocw.mit.edu.
Hi everyone. Today we're going to be doing trip prep and review, and so the first part of trip prep, this would work better if I were actually projecting, wouldn't it? So trip prep and review, and the first thing we're going to do is presentations. So each team has like 15 minutes to present, and then 5 to 10 minutes of questions, and then we'll go through a review of a few things that got missed or badly presented previously, and then going over trip prep, and then there'll be a little bit of time for you guys to work in teams on a few critical things. I also need to talk to every single person who's traveling, just one-on-one. It's a D-Lab requirement, so we'll do that. Yeah. Are there any questions before we start with the presentations? Okay, cool. So, ASA Phoenix, if you guys want to go first, that would be awesome.
Alright, so we're ASA Phoenix. I'm Carter.
I'm Buzz.
I'm Rosser.
Brianna.
And our team mentor is Ken. ASA Phoenix is a small Nicaraguan NGO. We're based in 2 areas, El Roblar and Puertolitos. And there are 4 products that we're looking at right now. One of them is the OJ sealer, which you guys might be aware of. The next would be the millet thresher, the washing machine, and the biodigester. So we're going to hand it off to us.
So the OJ sealer is a project that was a D-Lab project previously, and we're going to deliver it. So I should be giving you their group names, but I'm sorry, I don't have that right now. But it was a previous, it's not our project, so don't want to take credit for it. But we're delivering it to the community down there, and the purpose is to be able to seal orange juice so that they can sell it at a later date when oranges, like during the harvest when oranges are just so plentiful that the cost really isn't worth selling. So if they can bag the juice and then sell it later, they'll be able to make money from their harvest. So how it works is you have, it's kind of like the sealers we use in the lab, and you bring down this lever here, and then you can latch it. There's a latch that secures it in place, and that's like a safety feature, and also ensures a good connection between the metal and the plastic, so that you can get a good seal, and also you can't just kind of jolt it or lift it up accidentally, and then you end up with a mess and possibly an injury. So there's a latch, there's a switch that you press, and then it heats for 10 seconds. You can adjust that time. We'll have to, I guess, optimize that time. It's 10 seconds now. From what I understand, that's arbitrary. So we might adjust that time. And there's an LED that lights up while the rod is heating, so that the user knows that it is hot and not to undo the latch and open the rod. So this project, in 10 seconds of heating, and the metal that's used heats up very quickly and also cools off very quickly. So in that 10 seconds, after that 10 seconds over, you allow like 5 seconds of cooling, and then you can open the lever safely. So we're going to go down and implement the project, and some of the instructions that we'll have to give are kind of how to handle the plastic waste that they have, because they're most likely not accustomed to having the sheets of plastic, and what to, make sure they understand the consequences of littering in the environment, and then also explain the operations.
You're next.
So when we were first getting the groups and the projects and stuff, there was mention of a feed chopper. Well, after talking with ASA Phoenix, it turns out that they're actually interested in is a different part of harvest processing is threshing their millet crop. What that means is taking the all the little seeds are within like they call them florets, little stalks on the big one, and removing all the seeds from it, separating the stuff you can eat and stuff you can't. So these are a couple different designs that have been built by various groups. They're both, you can't see the actual mechanism that's doing the threshing in either of them, but it's basically they've got like little spikes on. I think this one has 2 drums inside each other with little spikes that are just knocking the seeds out, and this one they've taken the tire off the wheel and they're using all the spokes sticking out of the frame of the wheel to break it off. We didn't, since we only found out what the project was very recently, we haven't done much thinking about our own designs with this stuff. We're wondering if these are high enough capacity though. So things we're mainly on the trip we're going to be like getting information about the process. It's not something we're familiar with, you know, what you need to do to thresh the millet. Their harvest is 4,000 pounds, so we need to know how much that actually is, so we can get an idea of how much we need to be threshing at a time. And then there are different varieties, so we need to know what variety they're using, which will help determine what the appropriate method of threshing it is, how long they need to do it, and they're currently doing it by hand, and how efficient is this? And there was discussion about moving the machine between different communities, and so whether the different communities are harvesting at the same time or not is going to affect how fast it needs to work. Because if everyone's harvesting at the same time, that's more people that need to get their harvests done within a smaller amount of time. But if somebody a few miles away is lower elevation and has the harvest slightly earlier, that gives us more time spread. So the preliminary specs, they're currently taking 4 days to thresh the harvest. We could get that down to 8 hours. All of these, I'm not gonna go through and read them all because they're mostly very arbitrary at this point, and for this project, it's going to be a lot of information gathering.
Okay. So the next project we wanted to look at was a washing machine. Interestingly enough, we were kind of so gung-ho for this that we kind of leapt through and did the most planning. And it turns out that ASA Phoenix said, no, we'd rather have you focus on this. So, you know, that's part of the planning process. But in any case, oh shoot, chart not come through. Anyway. So there's some key things we want to keep in mind for the washing machine are the preservation of water. There might not be that much water to use in this community. Also, Phoenix really also wants to utilize the gray water to do something useful rather than just dumping it. We also have a couple different variables to consider. So D-Lab has done a lot of work with washing machines in the past. This is one of the designs they've come up with. Benji's not here right now, but he also showed us one that he did for D-Lab design that was a similar design like this. So we kind of took this and ran with it. This is basically the same idea except using direct drive from a bicycle that can be detached and then still used as a bicycle instead of a bicycle that's kind of gutted for parts and mounted directly to the thing. The kind of key variable we'd like to test here is whether to do side or top loading. That kind of depends how efficient and easy it is to load. We'd also like to kind of alter and play with the inner drum design. Should we make it out of rope? Should we make it out of chicken wire? Should we were thinking for a while of doing kind of nylon bags that we would pin in place so that would kind of spin and be their own rotors. And then also kind of draining methods, so again we can preserve as much gray water as we can. Sorry, I had a spec sheet and apparently my OpenOffice format kind of ate it. But they're all into it.
And then the project that ASA Phoenix wanted us to focus on was the biodigester. So what this is basically they wanted us to find a way to efficiently mix up the slough and based off their current concrete and plastic bag method. So here are our spec sheets. Basically you want it to be hand powered or bicycle powered. The main requirement being there's no electricity needed. We need something that stays in the same scale that they already have, 4 to 10 cubic meters. And then after one use they want to produce about 1 cubic meter of biogas, and should take about 2 to 3 hours to complete. Those are the main specs that they wanted us to achieve. Upon further discussions with ASA Phoenix, they showed us that this is their current design, and they wanted us to actually not focus on a method of mixing the slew, but actually find a way or a method to determine overflow, improve their current process, and find a way to gauge how much biogas they're producing at any given time. So right now what's happening is you can see the plastic bags in the background, and the biogas is delivered through this tube from right to left, and then as there's an overflow, it goes down this pipe and bubbles in the water. So if any user were to see bubbles throughout the water, they would know that there's being overflow usage. That being said, you don't know how much is in the tubes until it's too much. This can only determine whether it's overflowing or not, and can only be told. You can only tell that if you're there and see the bubbles. So if you're asleep and it starts bubbling, you won't know this is happening, and so they want to find a new method to determine how much biogas is being produced. So we changed the whole project in regards to this instead of a mixer, and started looking at the sort of manometer pressure gauge system of how to determine how much gas is there. So we're thinking about throwing basically just a rubber tube, having a fixed diameter circular object such as a soda can, plastic bottle, something of a fixed diameter that's common there, and we would wrap the plastic tubing around it and fill it up with water, and we'd make sure the water levels are even, and then we would release the valve, and so you can see the pressure difference between the water, and that head head difference is how much pressure there is inside. And then we'll have markings saying, like, if it's this much head difference, then there will be, blank amount of pressure, which means, 0.6 cubic meters of biogas. And then every day they can check out how much biogas there is because of the pressure difference. And then once they hit a certain head loss difference, then they would know they're reaching their overflow capacity. This will help them determine how much they have and how much they can use. So let's say if they wanted to use some and they weren't full, they wouldn't want to try to use 0.25 cubic meters if they only have 0.1. So this is the biodigester and some key activities. So basically just a quick summary of our projects. The OJ sealer.
Yeah, so this outlines kind of what each project is going to accomplish while we're down there. So we're going to deliver the OJ sealer and explain its uses and benefits to the community. And then for most of the other ones,
we can observe the shelling process for the millet, or inquire into it if it's not an appropriate time to observe it, and gather more information.
For the washing machine, we'll determine which research will be useful. We'll look at how they wash their clothes now and just how we can optimize that with our machine.
For the biodigester, we want to go there, see their current method, and see how we can implement our process and see if we can help teach them our preliminary concept and get feedback from them.
And then overall, just kind of objectives for our trip, we also want to explore a typical Nicaraguan hardware store to see, like, if we were to give them a design for a project, what materials they have available like at hand, and then also develop the relationships with the community partners down there so we can continue working as a D-Lab program with them, and then just take all necessary measurements that might be helpful related to each individual project.
And finally, we'd like to give acknowledgments to Amy, me, Ken, D-Lab, MIT, and ASA Phoenix. Any questions?
I'm going to give other people a chance to ask questions, but I have a few questions and comments. I'll start, I guess. So one is, did you get the sealer working? Were you able to connect it to a power supply?
Yeah.
Okay. So you should do that before you leave to make sure it's still working, and preferably real soon, so if it's not working, you can troubleshoot it. And you might also want to drill into that plastic box so you can make the timing adjustment.
Okay.
I know that the timer was set for 10 seconds because with the plastic bags that this group was using, that got them consistent good sealing, even with like orange juice flopped over or in the sealing zone. But we don't know what bags will be used by ASA Phoenix, so that's why you want to be able to adjust it. But yeah, it's pretty critical that you don't bring it and then be like, oh, it doesn't work. Like, it'd be good to know why it doesn't work at least. So it'd be good to know before you leave. For the millet thresher, I don't know if you were referred to Donna Cohn at Hampshire College, but she's been working on pearl millet threshing a lot. And so she might be a good resource, both in terms of ideas as well as I know she's been trying to grow pearl millet out there, and so if you do end up working on this project, one of your challenges will be not having access to the thing you're actually trying to work on, because you can't bring it back from Nicaragua without going through the U.S. agricultural stuff, and that's going to take longer than the rest of the semester probably to get through. So finding out from her if she is in fact growing it, if she does have a supply, would be pretty useful to know if the project's going to be viable. And then I liked your list of sort of universal things. I do have some lists of products available in general Nicaraguan hardware stores that I can send you to. But I definitely visit one and get a sense yourself. I would also encourage you to identify other projects that they might be interested in, either for this year or for future years. It's nice to just have an ongoing list. And then finally, with the millet, beyond just getting information, if it's being harvested now, if they have some, doing some experiments to really understand what sort of operations thresh successfully as opposed to not, and then also just documenting as much as possible about their particular millet, because there are a lot of different varieties, and so if they don't work with pearl millet but something else, or Donna has a different version of pearl millet, it'd be good to know what the differences are. So
one thing that we want to do with all the projects is see their current process and identify key aspects of what they're actually doing and how to sort of mechanize that. Yeah.
Cool. And then you guys were thinking about trying to build the biodigester sensor, right? Yeah. So do you have your materials list for that prepared, and you know what you're either bringing from here or what they can get there? Okay, awesome. Thanks.
Any other questions?
So hi everyone, my name is, we are a group of Phoenix. My name is Jessica, Liz, Vivian,
Sid. Juan.
and Kurt is here in spirit with us, all the way from Costa Rica. He's doing some field work beforehand. No, he's not. So in our presentation today, we decided that part of our project, which we'll learn about, is charcoal cookers, and we're gonna have to teach the community and teach them how to work with it. So we're gonna be presenting in front of this community, and we're not gonna have the PowerPoint or anything to help us with the presentation. So we tried to make this a little demo and see how we can do that to this crowd. So we're not gonna speak in Spanish today, but we are gonna try to let go of PowerPoint presentations today. So a little bit about our trip. So in today's presentation, I'll tell you a little bit about our trip, and we'll walk you through each of our projects, our final sketches that we have, what we're working on right now, and what are some final calculations that we want to do before we head out there next week. And I'll just start with some little bit of background. So we'll be visiting Ocotal, which is like 20 minutes. No, we'll be visiting Grupo Phoenix, which is like 20 minutes outside of Ocotal, which is north of Managuas, which is Nicaragua's capital. And we're going to be basically working with a group called with a group of women called the Solar Women of Totogalpa. And they are, again, a group of around 25 women that are interested in solar design, they've designed their own solar cooker, and you know a little bit about that background information. In our trip, we're going to try to evaluate. Our main objectives are to evaluate the existing products and brainstorm ways to improve. So working with what they have on site, we've already sent them the materials list of what they should prepare for us, stuff to do the charcoal burns, and stuff to just see what they have on site to work with them. And finally, we'll send them, and while we're there, we'll show them what we have in mind, and we'll try to sort of meet in the middle from what they want and what we have in mind, and make that happen when we come back. So first we'll start with the charcoal project.
So there's actually two parts to the charcoal project. The first is that we're going to be doing a charcoal burn with them. They've actually been taught how to do this before. They still have the materials from last time, so mostly we're just going to sort of like refresh their memories. So I think a lot of what we're going to do in the teaching is instead of, doing everything ourselves, we're mostly going to kind of stand back and watch what they already know how to do, and then kind of like be like, oh, it might work a little bit better if you do it this way, and then show them maybe a little improvement that they can do. So it's kind of just making sure that what they're doing now is correct and trying to improve it a little bit. But then the other thing we're doing is working with the charcoal stoves. If you remember when you saw projects from previous D-Labs, there was this sheet metal stove that was all one piece and then it was cut up and then folded into this kind of like hexagonal shape with like a slightly open up top. So we're going to be trying to either improve that stove or come up with a new one, depending on their needs when we go there. So we had some ideas for improving that one. A basic one was just to add insulation. So if you add clay around the base of it, kind of like these stoves that we saw the other day, then that might help the insulation a lot. And we talked to a group of Phoenix, and they actually have a man in the town who has a kiln, and they said we can use it as long as we tell them when we want to use it. So we're planning on taking advantage of that and just actually trying that while we're there. Putting whatever clay materials that they have easily available and baking it, and then seeing if that improves its, how quickly you can cook with it. We're also going to try some other things like adding kind of like using chicken wire, some other easily available material on top of that, so that they can kind of like have not really a grill, but just like a surface on top of the stove on which they can put things, so it's more adjustable for sizes of pans. We also might need to improve airflow, but it kind of depends on which pans they're using it with, because as long as like their pans aren't perfectly fitting, then it has enough airflow. But if we need more, we can either, if we're using the clay, we can kind of lift it up a little bit, but have some holes underneath so that it can come up from beneath, and then the air can kind of like keep the fire going, or the charcoal burning. Or we could just kind of make the design a little bit looser, because it's held together right now by a string around the outside of the top, and if you sort of loosen that string a little bit, it actually might open up holes a little bit in the design to let more air flow through. But we also could design a new stove.
Well, yeah, so we're also looking at designing a new stove. From what we've seen, that what actually works is the stove that we had last time, the completely clay stove. But yeah, the one we saw last time that was completely full of clay that had holes through the middle and handles. So we're thinking of, because we have a kiln over there, we could just completely design the stove with the woman. Some of the improvements we were thinking about were adding handles that would be easy to carry and of a different material. Adding a door, which I also had, to increase the airflow, and also adding a tray so you can pull the charcoal in and out as much as you want out of the stove. And yeah, so while we're there, we're also just gonna look with the woman what it is that they actually cook, the heat they need, where it is that they cook, so if it needs more shelter or less shelter from the wind, how much time do they actually have to produce or to make the charcoal, how much time do they have, and how easy it is to actually place the stoves where they are living. So if it's really easy to carry up and put down, or if they need to move it, I don't know, a kilometer every day. And yeah, it's basically also cooking time and the available sizes and shapes that we can.
Okay, yeah, so the next thing we worked on is like the solar cooker project. Now, basically we approached it like 3 ways. We talked about the existing research that was already done. We looked into what they have currently. We looked into the product specifications, and we looked into the questions that we had for them. As far as the literature goes, so we looked into like what types of solar cooker designs like predominantly exist right now. And they're basically like 3 types of designs. You have curved concentrators, which are basically like you have your cooker here, and you have some kind of parabolic mirror which reflects sunlight into the cooker. And they're curved concentrators because the parabolic mirrors are curved. The second type is like a heat box, which is basically just a box which uses the greenhouse effect. So you have like the sunlight hitting the box, and then the box retaining a lot of heat. And then the third type is your panel solar cooker, which is basically like a box with like a hinged mirror on it, where you have sunlight hitting the mirror and then getting reflected onto the box. So those are the 3 types that predominantly exist. When we looked into what they have currently with them there, they basically use a hybrid between like the box the heat box heater and the panel heater, where some designs do have panels, but then they also use reflective surfaces inside to keep it warm.
So a group from Columbia University has been working with the solar women of Totogapa to develop what they currently have now. And it's, as Sid said, this box kind of solar cooker. The one thing we really, really want to focus on when we get there is figuring out why it's so expensive to manufacture. The women really pride themselves in like being able to make this cooker on their own. But so we want to see how we can work with them, like what they like about the cooker, and specifically what materials make it so expensive to make. So we kind of came up with a new final design that we might want to improve upon, and it's kind of like the same, but I think to really move forward with this, we really need to figure out the materials that are available to us, and stuff like that.
Yeah, like.
Some specs.
Yeah, I just wanted to really get real quick. So for the designs, basically, like we wanted to do two different types of designs. One was like where we were trying to improve what they have currently, and one was like we wanted to design something new. And so basically, we came up with two things. So this is an improvement. I don't know, and then we might pass it around later. But this is an improvement. At least what we think is an improvement on their current design. We think it might reduce material costs and improve efficiency. This design is kind of like a mixture between the curved concentrator and the heat box. Essentially, like this was trying to make like a pressure cooker. We weren't sure if there's a need for that, so that's actually one of our questions. We were wondering like how much food they actually cook using pressure cookers, but we didn't see any literature about them using anything like that currently, and we were wondering if it was possibly of any use. So those are the basic two designs we worked on, and then maybe we can talk about the project specs.
Yeah. So some of our specs are, it needs to definitely retain heat, so we'll consider like different types of insulation. It has to be able to reach high temperatures, whether they need to be cooking different kinds of meat or just boiling water. It also has to be able to withstand different weather conditions if it's going to be sitting outside because it is a solar cooker. The climate in Nicaragua is kind of humid and it does rain a lot, so that's really important. Needs to be affordable, which we've already mentioned before, and easy to manufacture, or fairly easy to manufacture.
Yeah, we actually came up with like a bunch of them, but these were what we thought were most important. Another thing that like could play a role is how aesthetically like pleasing it is, because like we did come across literature where they refused to use certain cookers because they didn't like the way they looked. So that's a very important part also, which we're trying to work on. So yeah, that's pretty much what we're working on right now.
Great. And so last but not least is the solar cell phone charger, and I'll be speaking on behalf of me and Kurt for this one. So two key findings that we had in our literature research were just a comment that solar is the most flexible and efficient of off-grid chargers, and we thought, we were like, yay, thumbs up. And they gave the rule of thumb that about 60 minutes of charging would mean 10 minutes of talking on the phone. Now, the specifications of what kind of panels you're using and whatever not, all that can be optimized. So that led us to one of our design considerations, which is in the schematic, basically a communal charger. So just having, instead of one small solar panel, enough to charge one cell phone at a time, having a big like sort of communal charging station. But of course that requires the field work of being there for this weekend, realizing whether these people can actually work together, whether there's going to be a risk of having your charger stolen or having your cell phone battery stolen while it's being charged, or whether you can have some kind of like system where you leave something that's yours and that doesn't get stolen while you take the battery. So seeing how that works, what the different kinds of batteries that they're using in their cell phones are. And so one idea that also stems from that is having a sort of like port that's adaptable to different kinds of cell phone chargers, because if they change the cell phone, then you're not going to throw away the whole charging station. So that's some of the ideas that came from that. And another thing we were thinking about was a design consideration that they're going to be using their cell phones on the fields. A lot of time they'll leave home, they'll go work on the fields, they'll go look for food, whatever it is, and they'll have their cell phones on them for a long time. So if they ever have it with them for longer than needed, they won't be able to like come home and just charge it or plug in their charger that they have in their pocket into a wall outlet, right? Unrealistic. So one thing we thought is some kind of mobile charger. One technology that is a little advanced, I think, for our skills right now is it's a layer of solar cells that's integrated below the LCD screens of the iPhones. But we thought that something to that effect where the women could carry it around with them. And the idea of the solar cell phone charger for the iPhone is that you can carry it in your pocket with the LCD screen towards the outside, and the rays just hit it, and it's charging as you walk around, kind of thing. So we thought that'd be a really nice idea if we could kind of like Velcro pouch, make like some kind of Velcro pouch for the men and women that are carrying around, and then it could like charge as they go or something. So a little more reliable of a technology, but that takes a little more research, and if they even need that kind of design consideration. So some of the project specifications that we are keeping in mind are the ones that I just mentioned. The idea of maybe having a charger that's not powered by solar radiation, having different types of phones, and whether so instead of having different kinds of phones and needing to have different kind of connections to the phone, like what we usually use, just taking out the battery and seeing how that can fit into the adaptable ports that I mentioned earlier, and being able to charge your phone day and night. We usually come home and we like to charge our phone while we're sleeping, wake up in the morning, pick it up and go. If it's a solar charger, you would need the sunlight, so that's a little trade-off, but we'd be working with a kind of energy storage in the solar panel that would be integrated so you can charge it at night and use it when you need to. And finally, of course, there's always the risk of, like with all of our other projects, of theft. We are going to be there this week, next week, also assessing, like, if you leave your solar panel on the roof, is there even a roof, first of all? If you leave it on the roof, can somebody steal it? If you leave it on the roof, is it going to be damaged? Is this something you want to be able to take in and out? What if we just set up a system where we have somebody, like a security guard for this charging station, and then maybe that's just, people are willing to pitch in if you have a more efficient charging mechanism with somebody, guarding the solar panels or something. So lots of little things that we've been thinking about. And I guess finally, I'll start what we're gonna do between now and before we go. In this past, I guess, 1 week, we've basically divvied up the work. So we've become a little experts in our little project. But one thing that we definitely want to do is that kind of read up on each other's backgrounds, all the literature, all the catch each other up to speed on every project. One thing that Amelia, which is our trip leader, suggested is that we do some back of the envelope kind of calculations, maybe take that with us, have that on hand, because that's one of the technical skills that are valuable, right? That's why we're there. And so just to keep those numbers in mind, and anything else, guys?
We've had some correspondence with our community partners, and one of the things we asked her that I thought was really important was there going to be an opportunity for us to cook with the families? And I think that'll be a really good experience. And she said there will be, of course, but that'll be a really good experience because that will just help us strengthen our relationships with the community. And also, I think a question that we want to know from the solar cookers is, are they using the current solar cooker now? And what are the benefits of them using their wood charcoal methods, or however they're cooking predominantly now, versus using the solar cooker?
Yeah, it should give us a really good opportunity both for the charcoal aspect and for the solar cooker aspect to just see what they need to cook, how often they cook, how long it takes right now. Are they cooking indoors or outdoors, just everything. And so if we cook with them, it'll both strengthen the bond but also answer all those questions we have.
And that's us.
So some thoughts. You might be wanting to bring a thermometer and or thermocouple data logger with you for doing some of your stove measurements.
What was the last thing? Thermocouple?
With the data logger. There's a book on the Gico stove, which is the stove with the ceramic in it, that explains pretty clearly how to construct it, as well as the specifications for the ceramic, because only certain types of clay work for a Gico and provide good insulation. And I don't know what will be available in Nicaragua. It's rather different as a continent than Africa, so I don't know how that'll compare. I know some feedback that I've heard on the stoves is just a different height and or size. That the original design was designed to go inside their existing wood stoves, and a lot of women preferred for it to be freestanding. So that would be another area of investigation. For the cell phone charger, I think definitely investigating whether individual chargers or a shared charger is preferable, and sort of figuring that out. It's hard to say at this point what people would actually want, and so really spending the time asking the questions to learn that. And also phone usage, like you just mentioned, like standard stuff is that most of us probably charge our phones overnight and then use them during the day. Is that what their usage looks like, and is that their ideal scenario, or is charging during the day and using it during the night preferable? Like there's no telling without asking those questions. And I think Amelia's suggestion of running through those estimations and back of the envelope calculations, that you have them on hand to modify and adapt while you're in the field, is a great one for every team. So
I had a question on that. There's some mention in like our syllabus or something about having a journal that D-Lab would provide for us. Are we gonna get those soon, or because then we could put our calculations in that, or should we just do our own? Are we not gonna get those, or?
Yeah. So I will.
It's fine if we don't. We can.
No. So
I'm sure, but.
just to clarify, so last year we did give out journals, and a lot of the D-Lab trips gave them out and found that most students didn't use them and preferred to have their own notebook. That was the form factor that they preferred the most. So it's hard to make a notebook that works for everyone, which is why when you go to Staples or wherever, there's like 12,000 notebooks. So what's been proposed is that your trip leader has the notebook that's like the standard one that D-Lab makes. You guys will get subsections of that notebook just as like a pamphlet, or a stapled document that just has like the emergency information and some Spanish and things like that in it. And that each one of you bring your own notebook. If you are like, no, I really want the D-Lab notebook, I think we could do that by Friday. So let me know. There's a list of things you need to let me know by the end of class today that I'll be talking about. So if you could add that to the list if you do want a notebook, that would be good. And otherwise, you can bring your own and then just start populating it now. Cool. Any other questions? Yeah, sorry.
Did anything jump out at you guys? Any ideas that you might have had?
I was gonna say, have you guys seen that portable light project? I actually have a little slide on it, but it uses those flexible solar cells, and you can put it on. What they've done is they make a bag, and then they just open it up, and it becomes a light. But something like that could be used for carrying around, if it's a bag or a skirt or a scarf. I don't know, depending on what people are using, but it could be something that's sewn into whatever people wear during the day to charge it.
That's a great idea. It's flexible solar cells?
Portable. Yeah, it's like super thin.
Okay.
There are flexible solar cells.
I thought about that, and I thought it was a professor had mentioned that he was researching that, so I was like, oh, that's not out yet.
No, it is
actually.
Yeah.
Okay. Sure, look that up.
I don't think the electricity team uses the flexible ones. They just have small ones. They're thin because the problem with the flexible ones is their efficiency is lower, but they are great.
Yeah, it's whatever.
And then the only other thing to think about if you're going to do wearables is thinking about where you're actually going to get direct sunlight, because are people outside enough? And if the idea of putting the iPhone charger on your pocket concerns me from how much direct sunlight are you going to get? Because if you recall that you need to be perpendicular to your panel, and so sunlight tends not to be perpendicular to a human body. So just thinking about that, that's one of the challenges with wearable solar panels, is making sure that they're actually in the sun enough.
I thought that one consideration might be like, we were studying this with the water, with like the first lab we did of carrying water, right? If they're actually making long trips, that's a pretty good time to just, if they're carrying it on their backs, if they're carrying the load on the back, then like put some sombrero on or something and put the solar panel on top, and then
so I think it's investigating what is actually happening, what are people actually doing, And you will find roofs there, so you don't need to worry about lack of roofs.
We will find what?
You mentioned you weren't sure if there would be roofs, and people do have
Roofs.
Yeah.
Okay.
They do have them.
So that's us.
Cool. Thanks.
Okay, so we're ASA ProStar. I'm Banzaert.
Julia. Bessie.
Adrian.
So we haven't had like much communication with ASA ProStar yet because they're a new community partner in El Salvador. So some of our projects are kind of just our ideas and what we would like to see or would like to implement. It's not necessarily what projects that we're actually going to be working on while we're down there. We know that we're definitely going to be doing a charcoal burn, but other than that, it's kind of up in the air. But ASA ProStar has a kind of focus on rural areas and needy communities, so we're thinking that we're going to be in a rural area. Still not sure. So we aren't totally sure about the exact projects. We're looking at ventilation for cooking in the houses, charcoal stoves, and lighting improvements. So, like for instance, with lighting improvements, we don't know what kind of lights they have. So those are questions that we need to ask when we're down there.
So just to introduce some of the things we looked at, we just created a library with like an image and then just key phrases of what these things are. And as Benzi said, I think most of our time there would actually be asking questions. We've come up with a lot of questions just to really get to know what people need, and then work with them as opposed to come up with some idea and just try to impose it. But so in terms of the ventilation or using stoves that make a lot less smoke, we've looked at, for example, the first image is the solar chimney, which is a hollow wall that's built into the space that pushes the hot air out, and cool air comes from the other side of the house. So I guess simple spatial techniques that can create more airflow. Depending on where the stove is, we can get a lot of the smoke out of the house. Some of the stoves we looked at were the Upesi stove is one of the first ones, and it's clay. A lot of them were very similar, and some of them were mentioned from previous groups. But a clay stove that usually has an opening on the bottom and a metal piece on top. The clay is used for a little bit more insulation than just a sheet metal. And this, it's made with ceramic or mud, and it's something that could be or is made by women, and it could be sold for profit. A couple of the solar cookers are another idea. And they were mentioned before. It was the two that I looked at. One was actually an MIT project done a couple of years ago, I think. And so both of them use reflective surfaces to get the light and focus it onto a surface to heat up food. The Ecochina is, and then the other one, the O'Neill stove. They're pretty similar. They're cast from cement or concrete. They similar to the one of the Upesi above was that they have an opening on the bottom and a metal plate on top that's used to heat the food. They produce a lot less smoke, and because of the insulation, the fuel is actually reduced by about 60%, which is great. The one on the bottom is an improved 3-stone fire stove, and all it is building. It was a series of steps used to show how you can actually build a stove with clay and using the bricks, and it's not portable. It's going to be built and used where you want it, but it has an opening on top and usually a hole on the bottom for airflow and to feed the fuel. Some of the charcoal stoves that we looked at, and we've talked about these, the Jiko, this other one below is very similar design, just a little different. This one uses clay and it has the holes, and the one on the bottom is again something that we saw that has you can control the airflow by the different openings, the door openings or openings on the bottom or on the sides. So depending on how much, I guess how much we need it to heat up and how much air we want to let in.
In terms of the lighting, this first project was actually the portable light that I mentioned, and what they do is they make a bag and they put these flexible solar cells on it so that the women, when they carry it, it charges, and at night when you open it up, it uses these reflective and diffuse surfaces actually to make the most use out of the light source that they use, and it's usually used for studying. It has enough light to study at night. Some of the other light sources we looked at were solar lights mostly, whether portable or stationary, something that can be charged during the day and used at night. And they come in so many different varieties. Flashlights, these bottom ones you can hang from the ceiling, you can carry anywhere with you. So they're all in a way common that they use a solar panel to charge, and then the actual light source is different. But actually the idea that the information that we know about the communities is that they actually do have access to the grid, but they have very few light bulbs, or I guess they don't have that much power out of it. We're not really sure yet. But so in terms of looking at precedents, we weren't really sure what these things could be, but we have some ideas of how we can use as little light as they have in order to brighten up this space as much as we want. And these are some of our ideas.
Okay, so as Julia said earlier, one of the main problems in these communities is the existence of poor ventilation. And a lot of these houses use wood burning, which, as you know, when wood burns, it releases a lot of toxins in the air. So our ideas were mainly to move the smoke out of the house, or to clean the smoke as it leaves the house. So one of the ideas that we had was the smoke dispenser, which the way it works is the pot is put on the stove so that as the pot covers any way for the smoke to be released into the house, and instead it forces the smoke to go outward to someplace outside of the house. And we also employ the use of these rings, which serve to accommodate different sizes of pots that they may have. And another idea that we had was the smoke filter, where the idea was, as the smoke rises over the stove, it would pass through possibly a wet towel, and the wet towel would clean the smoke as it would leave. So a couple of specs that we noted were, of course, low cost. Of course, these places have low income, so they have to be affordable to these people. It has to be easy to assemble. You don't want something that's going to take 6 months to assemble, so we decided that it should take less than 2 days to put together. Ease of repair was very important. In case any of these things break down, it should be easy for these people to get parts to repair their stove. It should be effective. It should be able to increase the air quality of the house by about 60%. It shouldn't interfere with their cooking. A lot of people, they like the space that they have around their pots because that's what they're used to, which is why also in the we made the smoke filter so that it was able to be stowed away, just for aesthetically pleasing to the users. Should be easy to use. Obviously, these aren't things that these people are used to using, and so it should be easy for them to get used to using them. And it should be easy to maintain. For example, with the filter, it shouldn't have to be replaced after every use. We estimated that maybe about less than 3 times a week. A couple questions that we had that will make us more able to solve these problems is, what's the family's average income, and how much are they willing to pay out of their average income for these stoves? Where in the house is the stove located, and is it movable? And can we possibly put it outside of the house? What is already being used in their homes to ventilate? What materials are in the area are available, such as the metal and curtains that could be used for our ideas. We also wanted to know how they store their pots and pans and if we can incorporate that into our ideas. And we also wanted to know what the house setup was like, are there windows or the openings for a smoke outlet instead of us having to break a hole in their wall. We figured they might not like that. Benji's now going to talk a little about the charcoal stoves.
Alright, so a lot of the ideas are very similar as we saw. They had sort of different features that we thought would be useful, sort of depending on what the preferences of the users were. And so we sort of just attacked it from a general standpoint of like what the general shape of the stove would be and what sort of the key feature would be that we wanted to highlight. And so these are two of them. The first one is basically like a sealed steamer. It sort of looks like a vegetable steamer. I don't know if you're familiar with those, that they sort of open and close. They have like overlapping layers, and so it can basically accommodate just like a variety of sizes of pots and pans, but it still maintains the seal all the way around the pan, assuming that it's circular. And so that's sort of the idea, and that's just, we don't have any specific designs for that, but you could incorporate the airflow or the insulation as needed. So we didn't really focus on the specifics of it. The second one that we thought about was it's actually very similar to the one that we saw back there before we saw it. It's a funnel basically that has a small enough opening at the bottom and a steep enough angle so that the charcoal gets jammed within the funnel. It's something that happens all the time, like if you have marbles or anything, they get jammed. And so this allows for airflow to come up and for ashes to fall down, but for the larger pieces of charcoal to stay. And so we thought that was just an effective but simple way of keeping the charcoal in and having just a simpler design. And it also accommodates a variety of pots and pans because of the funnel as it goes out. So the things that we wanted to make sure and maintain were its effectiveness as a stove. So we wanted it to cook the food just as well, right? Like who would want to switch to a stove that doesn't cook as well as your other one? So that one is definitely number one. And we wanted to maintain its fuel efficiency, not using any more fuel than they do right now, because that also there's no reason to switch to a stove that's less fuel efficient. And we also wanted it to be affordable, so that there's a reward for switching, and also pleasing aesthetically, and that it accommodates many pots and pans, just so that there aren't any sort of barriers to keeping people back from using them. So the questions mostly revolved around what currently exists in the places. Like we said, we don't really know much about our partners there, so we'll mostly be asking about materials that are available, like what they usually use, what their habits are in terms of cooking, and why they don't use charcoal or how much they pay for fuel. So all these sort of basic questions that really outline the needs of the community.
So I'm going to be talking about improved lighting. And so we basically came up with two general ideas that could be feasible. Once again, like we said, we really don't know a whole lot about what we're going to be doing at all, but this was something that they recommended that we might look into. We don't know if this is feasible or not, but basically what we came up with was the idea of first a white room, which is just going to, essentially like what it sounds like, we're just going to maximize the amount of lighting via like reflective surfaces. So we're thinking about like reflectors on the ceiling, having white curtains blocking maybe windows and stuff, and then painting the walls white in color so that what light comes into the room, it makes the room look lighter just in general, because if you have like dark colors on the walls, it makes the room look darker, smaller. So the second idea we had was this concept called the sunflower, who's kind of like, it's sort of kind of like an umbrella that can be used to direct light in certain areas that you need. It can swivel and go up and down based on where you want to direct your light, whether you want it to illuminate most of the room, or if someone's staying up later than another person, perhaps to study or to prep for activities that would take place during the following day. You don't want to interfere with anybody sleeping or such. So that is why we have it directional. And we have the you can adjust how much light's directed by twirling it around, and then also by how much you open and expand it. Some project specs we came up with. We want obviously it to be very flexible and to have multiple uses. So basically for different tasks that you might have, whether it's for cooking or for reading. The ability to direct your light, so where you can turn the light that you choose to be directing. We want it to be affordable and reliable, and these are questions we don't necessarily have a value for because we don't know who we're working with, so we don't know what would necessarily be reliable or more feasible. And obviously, like the efficiency of light, the quality of light, we want to be able to improve the lighting by about 50% and has as much brightness as we can. So obviously we're going to have to ask a lot of questions, such as what types of light bulbs do they currently have available, how many light bulbs they currently have available, how much power do they have access to, how much light does each customer need, what type of activities do they do would also contribute to the type of lighting they would need. If they just need a little bit of lighting for walking around and such, then it doesn't have to be as bright. But if they're reading and they're studying, obviously you're going to need a lot more direct light. And also how much are the customers willing to pay. And also one of our main ideas was the idea of a white room, but are they going to even have access to white and lighter color materials? Obviously that's going to make that entire design moot if they don't. So, and where is their light bulb currently located? Like, is it wired into their house, or is it more of a portable nature? And then, do we need like direct daylight into dark spaces? So, those were some of the questions we were asked, and so we have some expected activities.
So while we're down in El Salvador, we're going to do a charcoal burn demo. We're hoping to first demo to kind of a group of people that are more interested in this, who could learn and kind of be like our liaisons to the community, so they would learn firsthand and then kind of help us with a second demo to the larger community. And then we want to talk about cooking indoors and find out what they're actually doing and if they're aware of these dangers. Talk about charcoal usage and how or charcoal burn would be effective if they switch to charcoal stoves. And then just discuss what they use for lighting now and figure out how we can improve upon what they have. So a lot of it's just me investigating in the field and learning about their living habits and how they work with what they have now.
Any questions?
In regards to the one with the ventilation with the wet towel as well.
Yeah.
How often do you plan on replacing this filter, and is it cleanable, or do you usually use a towel? Or?
So the idea was that it would have to be replaced maybe less than 3 times a week. So like maybe every other day at most. And as far as cleanable, I mean, I guess it could be cleanable if it's a wet towel. But we still need to look into that.
Yeah, I mean, we're not filter experts, and like the particulates are really, really small. Like that's what makes them really dangerous, and so like a wet towel wouldn't necessarily take take the very dangerous things, but we don't know. Like, what if a simple thing could really improve that? So we haven't really done any specific research into like how to improve filter efficiency, but yeah, sort of the basic idea.
So I would definitely, like, before proposing that idea,
Yeah.
I wouldn't propose an idea that you don't actually know if a wet towel will provide any effective filtration. So it's something you could look into, is this feasible? But I wouldn't discuss it as an idea that has merit to the people that you're working with until you know if it does. And from an experimental standpoint, we have the capability to run emissions tests in the lab. I don't know if we can pull off running it before Sunday, but we might be able to, or certainly when you get back. You should definitely, like, it seems like you are well being prepared just to be flexible and figuring out what's going to happen. I think you did a great job given the lack of information you had. Along those lines, I would try calling the community partners today. Like, there's 2 that we have phone numbers for, so call them both. Does anyone speak Spanish on the team?
Well, we too do, but we're not.
Right. So you could help on the phone today.
Oh yeah.
So that would be good to start. And then finally, just stove quality. There was a lot of designs there, and some I think have more merit than others, and this is true for Grupo Phoenix as well to think about. that you should definitely check out those 2 links I put on the charcoal lecture, which is an organization called Aprovecho, and then I think it's called cookstoves.net, because there's a ton of cook stove designs out there, some of which are really great, like the Jico, and others of which are getting sold and do not actually improve efficiency or emissions at all. And it's really easy to just say, my stove is better, and get a website up and get some funders without actually doing any due diligence that your stove is in fact better. And so it's easy to make a stove that's worse, and you don't want to be doing that. So, cool, that's all I've got. Thanks, guys.